Now, what we did here is, since week 3, we worked only with cash flow. We give you a cash flow. The cash flow from a stock is a dividend. The cash flow from a bond is the coupon and the face value that you receive at the end. The cash flow from a zero coupon bond is just the face value. So in a project, you have multiple cash flow. In this case, they are all the same, but it will not always be like that. So you have different cash flows. And what do we do with those cash flow? We have to decide, are we going forward with this project or not? So we have to make a decision. So let's make a decision. Let's use what we saw in class in order to make a decision. So let's compute NPV first. Let's use the function from Excel, NPV here to say rate. So I will use rate, that's 0. Or use the rate 7%. Keep in mind that NPV function in Excel is not a real NPV function. NPV in Excel is a function that is in reality a present value function. So the first cash flow always comes in year 1. So I will have the present value of everything, and I will add the cost. And since it's minus cost, but the cost is negative in here, so that's my value right now. So should I go? Remember, if it's smaller than greater or equal to 0, then go. So that's a no-go. So now let's compute the internal rate of return. We'll use Excel, and this time the first cash flow is at time 0. 6.84%. Remember, if it's greater than the trigger, which is the required return, go. It's not greater than 7%, so no. So now payback. Payback, I will need to add some lines in here. We'll do money that I put in plus the cash flow that I get each year. And we'll see after how many years I'm done recuperating 10 million. So or what I can do just the sum of each cash flow. And look when it is bigger than 10 million, and it's bigger than 10 million after 9 years. So nine years it is. But in the data here, we have a maximum payback of 3 years. So it's no. If it's smaller than the trigger, here 3 years, then go. So it's no. Discounted. Remember, that's problem with this is that we don't take into account the present value of money, the time value of money. So let's compute the present value for each cash flow. We'll use the PV function of Excel. PV, 7%, number of period. And since I want to copy paste, I will use a 7% F4. The cash flow is 1.18 million. And a number of period is 1 year. Payment is 0. The future, because there is no cash flow each year. It's only one cash flow that I want to have the present value of. So I have a 0 payment. It's like your calculator with this 1.8 million. I want that to be positive, so I will change the sign here because the cash flow is positive. If I did it right, so that follows, and the required returns stay the same, so I can have it like that. There you go. And as for the discounted payback, I will do the same. I will do the discount cash flow plus the cost. The cost net of the last cash flow plus minus the cost. 10 million plus 1.8. And I will have the same, and I do for all the years, and it pays back after also 9 years, discounted. Oh, that's the right one. Here, I need a discounted cash flow, so here we go. Oh, and it's, well, never, obviously, the net present value after, so that's never. Remember, we will accept if it's smaller than maturity, because if it's smaller than maturity, it means that the NPV will be 0 after that amount of year. So if I have more year, it's something that just contribute to net present value, unless the future cash flow are negative, and then discounted payback, well, as payback is not a good choice, because it it totally forget all the cash flow that comes after the trigger, or after the payback. What happens after if there is a bunch of negative? Let's say we value a project of nuclear power plant. You have a big investment at the beginning. Then you have decent cash flow each year. But in order to decommission the power plant, you have to pay a lot of money. And if you are not a shady businessman, you have to take into account this cost of salvaging. The salvaging cash flow can be very negative. A lot will use a trigger like the payback, just because they want to use the same idea behind the payback. So, which will be 3 years here. Then go. But that's a no. Profitability index. To do profitability index, I will need to have the present value of the project. So I will do P as NPV. Remember, NPV is really a present value formula. So I will do for all the cash flows, or since I already have them, I already have the discounted cash flow, so I can just sum the discounted cash flow, and I should have the same result. And remember, profitability index is the present value divided by the cost. Here the cost is negative, and think about the cost, not only the investment, but all the investments that you need to do. So both buying the equipment, commissioning the equipment, and buying the inventory in order to be able to use this new machine. So that's 0.99. Remember, if it's greater than 1, greater or equal to then 1, then go. Smaller than 1, no go. So here it's obvious, everything is a no go. It's a no, 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 no. So Lucius has a good idea, but does not word it. And here, he's lucky, he has no tax to pay. But if I did my sheet correctly, I had some tax. Oh, now I have a negative cash flow related to taxes, and the net present value should be even more negative. Oh, wait. Do here. Ah, it was. Now it's right. I have no problem. I have no problem because the cash flow was always the same. Now it's not. It's not always the same anymore. And for everybody that said, "Oh, why we have always the same cash flow? Why we don't use the calculator?" and blah blah blah. And now you know why you cannot use the calculator, because if you had some tax rate, you see that the cash flow is not always the same. So the calculator does not work, and the formulas with the constant payment does not work. So you really have to use the present value of each cash flow, or the formula that exists in Excel for internal rate of return, and the NPV. So now if we have to pay a 20%, just remember that 20% is the tax rate, the flat tax rate for a company in the US. 20%, and you see that, it's even a bigger no-no. Obviously, we had already a no without tax. Now we have to pay taxes, so the no is even bigger. But which saving will make it a good idea? Excel has a good thing for you. So what you want to have? You want to have an NPV equal to 0. So let's go into data. What if goal seek? You want to have the NPV equal to 0 by changing, well, the question that I ask is which saving, how much saving? So let's change the savings, and I just let Excel find that I will need 1.3318 million saving per year in order to make this project a good project. And you see that NPV 0, internal rate of return 7%. Obviously, we were looking for the saving that make it so that NPV is equal to 0. Payback is now still 9 year payback here. Still even it's. Remember, but look at that. It's because there is a lot of cash flow at the end. A big cash flow at the end, compared with all the other cash flows. So that's obviously what make it that like pull the value at the end. For the discounted payback, obviously we want to have 0 on the maturity, and discounted payback is how many years until my NPV is 0 if I forget everything that comes after. So that's obviously by construction. And NPV, profitability index will be 1. So everything will be now a big yes. So that's about it. Thanks for your attention, and see if you have any question. You can write me an email, or you can ask in class. Thank you.